Thank you. Well, good evening, ladies and gentlemen, guests from the Kingston area, from Queen's University, from the schools in Frontenac County and other areas, from other more distant parts of Ontario and New York State. My name is Leo Enright. I'm a representative of the Royal Astronomical Society of Canada Kingston Centre, which has been a sponsor for this occasion here tonight. I stand here to say that on behalf of the Kingston Centre and Queen's University, I am very thrilled to welcome to our area the man who is quite literally the most distinguished and eminent astronomical guest we have ever had in our city. We welcome from the United States, from Las Cruces, New Mexico, Dr. Clyde Tombaugh, his wonderful wife Patricia, and Dr. Bernie McNamara of the Department of Astronomy at New Mexico State University in Las Cruces. For almost 6 decades now, Dr. Clyde Tombaugh has been known throughout the astronomical world as the man who discovered the planet Pluto, the man whose enormous dedication in the tedious search for the trans-Neptunian planet led to the exciting announcement of success in February 1930. I simply cannot help marveling at the kind of perseverance that was needed in those years to take the numerous photographs required for that project at the Lowell Observatory in Flagstaff, Arizona, to process and prepare and blink those images of millions of stars, and there were millions. I have myself observed Pluto on a few dozen occasions, perhaps with an instrument, or I should say with an instrument whose aperture is only a tiny bit different from the 13-inch Discovery telescope that came into use at the Lowell Observatory in 1929, and I can testify to its faintness and to the fact that observing Pluto is a challenge, though it is now fully a magnitude brighter than it was at its discovery. And of course, I have the precise list of coordinates and the numerous maps to help me, and the knowledge that what I am looking for is there. How appropriate to be talking of Pluto in late 1989. Just 6.5 weeks ago, the planet passed perihelion, and I understand that Dr. Tombaugh was at a perihelion party in California 6.5 weeks ago. Passed perihelion for the first time since its discovery, and something that will not happen again for almost 248 years. And at almost the very same time, we get an opportunity to meet its discoverer. Seeing this distant planet will have a new and special meaning for me whenever I see it again. Last April and May, I saw it a number of times, and recall that on the night of May 3rd, 4th, I waited at the telescope until 3 a.m. local time, just to be able to say that I was viewing it at the precise moment of its opposition, an opposition which happened to be the closest opposition in time to that of its perihelion point, even though at that opposition it may not be any closer to us than at the next one, next April. Yes, whenever I see it in the future, I will think of the very warm, kind, down-to-earth human being whom I have had the rare privilege of meeting today. I will think also of the awe and respect that my friend David Levy has for this man, and the wonderful stories he has told me about him. David, I should mention, has been working on Dr. Tombaugh's biography for the past few years, preparing it, and this book will be published by the University of Arizona Press about 1 year hence. David tells me about how Clyde maintained and has maintained over the years the true spirit of the amateur, the same kind of spirit that led him to build his own telescopes years ago on a Kansas farm, and to do the kinds of drawings of Mars and Jupiter that led to his being employed at the Lowell Observatory in the first place. I have also heard from David that Dr. Tombaugh is among the world's greatest punsters, and just at dinner a few hours ago. I guess I had evidence of that, didn't I? He has truly raised the art of the pun to new heights within the English language. I could not begin to list all the contributions to astronomy of Dr. Tombaugh. And as Terry said to me a few minutes ago, time has not diminished the accomplishments that took place back in 1929 and 1930. I would be here half the night if I were to try to list those accomplishments, and you want to hear him, not me. Let me say only that his interest in and contribution toward research in the planets and other solar system bodies has been very considerable. Not least among these contributions has been the setting up of a scholarship fund at his alma mater, New Mexico State University. And this lecture tour of 5 Canadian cities is a part of that project, one which will contribute toward research by graduate students in astronomy, and who knows, perhaps someday may lead to an announcement almost as exciting and momentous as the one of February 1930. For making the arrangements for this occasion possible, I wish to thank, of course, Dr. McNamara, David Levy, comet discoverer par excellence and a member of our center and a member of the Tombaugh Scholarship Program, my wife Denise, president of the RASC Kingston Center, and in a very special way, Dr. Martin Duncan of the Astronomy Group in the Physics Department at Queen's University. I look forward to this talk very much. Join me, please, in extending to them a sincere and warm welcome to the Kingston area. Dr. Tombaugh, welcome. They would like you to put this in your pocket, I guess.
Thank you, Leo. Can you hear me? Okay. Is it louder? Okay. Thank you, Leo. Ladies and gentlemen, boys and girls, I have a little confession to make to you. For 59 years, I've been a plutocrat. As he has introduced me, some of the aspects of how I came into this, I might mention that the thing that began to lead to it was the discovery of Uranus in 1781 by Sir William Herschel of England. And then as it deviated from its orbit a little bit, they suspected another planet beyond Uranus. And so 2 theoretical astronomers, Adams of England and Leverrier of France, did a lot of mathematical calculations and came up with about the approximate position in the sky where they thought it might be found. And it was actually seen for the first time by Galilei of Berlin in 1846. Well, then after several decades, some began to entertain the idea of a planet beyond Neptune. One of the first ones that made a significant search was Todd, who made visual observations of checking several thousand stars and over a strip of the zodiac. And he was looking for a disk with a high power, but of course he had no chance of finding anything. And then a few people in Europe, and also William Pickering and Percival Lowell in America, attempted to study the problem, and if possible from the residuals of Uranus, and Pickering from the epi of comets, where there might be a planet beyond Neptune. The work started in the early part of the century. Can you hear me all right? Okay. All right. Percival Lowell, who was known for Mars and its canals, became interested in the problem of a planet beyond Neptune, and he had done a great deal of mathematical work using the small residuals of Uranus that Neptune didn't explain this was very marginal evidence, but it was the best that he had. And so he predicted the planet, finally, after a lot of work, of about 7 Earth masses beyond Neptune's orbit, and approximate position of the sky, very roughly. And he had even predicted some of the orbital characteristics, some of them which had a remarkable agreement, and yet we know now that it was all a coincidence. So he started his search as early as 1905 at Flagstaff, and with 1907, and of course this has to be photographic, because there's so many stars in the sky, you have to record the sky, freeze the stars in a long exposure, then repeat the region a few nights later and compare the two together to see if anything has shifted position. This was a fundamental characteristic. Many people were quite surprised when they learned that I discovered Pluto in the daytime, scanning plates, not looking through the telescope at night. You wouldn't have a ghost of a chance of looking find it at night, because there are 15 million stars in the sky. It's brighter than Pluto, and it looks just like all the others. And unless you watched it for about 3 hours, you wouldn't know it had even moved. How are you going to watch 500,000 stars for each one at that time? So you see, the problem had to be photographic. Well, then, particularly in 1914 to 1916, the Low Observatory they borrowed a 9-inch wide-angle camera from Swarthmore College of Pennsylvania, and again attempted to find the planet X, and again were unsuccessful. It turned out that they took 1,000 plates of this instrument. Only 2 plates contained images of Pluto, and of course they were fairly dim, and so and they were examined on a blink comparator, but were missed. And the thing that really puzzled me very much was that these plates were taken on the 17th of March and the 9th of April in 1915, and they should have been taken in December, because at the position where Pluto was at that time, which they called Planet X, Pluto was near its western stationary, the worst possible time to look for the planet. The motion would have been practically nil. There have been a lot of some asteroids near the stationary positions, and I was really shocked when I found how sloppily some of the early searches were done. The way to do this is to take the plates at opposition, which is opposite the sun. It's that part in the sky where the full moon is located. Of course, we don't want any moon in the sky because that would fog the plates. But in this way, the Earth then, traveling its orbit, is traveling crosswise to the direction to the planet. This then causes all the planets beyond the Earth's orbit to appear to drift backward to the west. We call it apparent retrograde, even though they're moving eastward. And the further out the planet, the smaller the shift. And so by making use of this, I had the means of a parallax to determine almost at a glance about how far out it was. And so when I encountered this on the 18th of February, I knew instantly it was beyond the orbit of Neptune. I took these plates in January of 1930, and of course I did not know that I'd photographed the planet, and not until February, when I started scanning these plates under the blink microscope, did I find it. And of course it's a dim little fellow. Pluto's light at the time was equal to a candle at a distance of 200 miles. Now that's dim. So it's a little dim-wit, wasn't it? Well, so on that day of February, I had this great experience. Some people have asked me, how did it feel to discover a planet on that 18th of February? And I said, it was great. It made my day. Well, then this took place about 4 o'clock in the afternoon, plus or minus 2 minutes. I don't know the exact time. I was busy, of course, checking out with the third plate to see if it was genuine. I felt quite sure it was. And so then for 3/4 of an hour, I was the only person in the world who knew exactly where Pluto was. Well, my senior colleague, one of them, was in his office across the hall from me where I was doing this work, and this machine makes a clicking noise which could be heard in that end of the building. And he told me later, I didn't know it at the time, he said, I heard the clicking noise stop and a long silence. And he suspected I had run onto something, and that poor man was just sitting there at his desk in great suspense, waiting to be invited in for a look. Well, then I went down to the other end of the building to tell the director, Dr. V.M. Slifer. And the door was open, and he's working on some papers on his desk. And so I kind of paused. You have to realize I was in a highly emotional state at that time. And so I kind of paused, and then I wanted to announce it to him as nonchalantly as possible. So I said to him, I walked in, I said, Dr. Slifer, I found you Planet X. He rose right up out of his chair like a spring had sprung him, and with a look of both great glee and also some reservation. And I had to walk briskly down the hall to keep up with him as he went down to the room where the machine was, and Dr. Lampton was taking looks at the planet. So that's the way it happened on that day, and I never will forget it. Of course, it was about 6 o'clock. I managed it about 4 o'clock. And so we didn't get away from there until about 6 o'clock. And I was a bachelor then, and so I went downtown, as it was my custom, to pick up the observatory mail at the post office and go to a cafe for my dinner. Then I would come back up the observatory on a hill about 350 feet above the city, and I would, if there were no moon in the sky, I would load my plate orders, get prepared to go out to the dome to take the plates. Well, of course, Dr. Slifer said, don't tell anybody, this could be very hot news, and I didn't even tell my parents. And so they learned about this through the Associated Press. Well, and of course he said to me, they both admitted it was a very good prospect, and he said, rephotograph the region as soon as possible, because our last record was on the 29th of January. This was the latter part of February. Where is it now? Well, but that night was cloudy. You would know that something like that would happen. Observer's luck. And so I went to the Orpheum Theater there in downtown and saw Gary Cooper in The Virginian. I'll never forget that show. Well, I came out and it was still cloudy. I went up to the observatory and put the car in the garage and sorted the mail and loaded a plate over and sat up for several hours waiting for a chance for it to clear, but it didn't clear. So I finally gave up, went to bed. The next night was clear, and I got a plate on the 19th of February, and I expected that the image would be 10 or 11 millimeters to the west of the January 29th position, and sure enough, that was exactly where it was. So it was right on schedule. So the next night after that, the 20th of February, we went up to the 24-inch refractor at Lowell, which is the one they use for studying Mars and other planets, to see if it would show a disk. We were very concerned about that. And of course, we set the telescope circles, and we had a little film of the immediate field, started picking out the little faint configuration of stars, and there was a dim little fellow, very unimportant, looking just like the other stars in the field of the same magnitude. Well, this was sort of a disappointment, of course. And even then we began to be a little concerned whether Pluto was big enough to have a mass to produce what Lowell had predicted. But to me, I had a big kick out of it because we realized we were looking further out in the solar system than anyone had ever looked before. So when I encountered that on that one, about the images that afternoon, and knowing that it was beyond orb of Neptune in one split second, these things crossed my mind. I knew I'd become famous, I knew that the news would rock the world, and I knew it would change my life. How exciting can it be? Keats wrote penned the lines as follows. Then I felt like some watcher of the skies when a new planet swims into its ken. Now, I think I understood that better than Keats did. Then we prepared, then of course we started photographing on every possible night to follow it, and as it slowed down, as it veered from opposition time, as it should do, and prepared for the day of announcement to the world. We realized that it would be quite a lively time once the news was out. And so on the then I helped the secretary fold up hundreds of observation circulars and stuffed them in envelopes, and we packed in several boxes of these things to be dumped in the post office on the appointed day of the announcement to be mailed all over the world. Well, on the 13th of March, the director sent a telegram to the observatory trustee who was in Springfield, Vermont, and he in turn forwarded to Shapley the next day. And of course, then the news is out. And I tell you, talk about news and excitement, we had it. Then after, one of the rather interesting things, one of the great orbit computers in Berkeley, California, Dr. Leuschner, wrote to Dr. Slipher practically demanding the positions of the early images so he could be the first to calculate the orbit. Well, Slipher had his own ideas about that, and of course he didn't even give us one word of congratulations. I miffed Slipher, so to heck with him, he wasn't even paying attention to him. About a week later came another letter, this time profused with congratulations, and by that time Slipher didn't want to do anything with him because he had made a statement to the San Francisco newspaper. How did we know it was a trans-Neptunian planet until we had calculated an orbit? That man, with all the knowledge he had about orbits, did not know the simple principle of orbital parallax that I used to identify it. Now that's strange, isn't it? Well, of course, the letters poured in by the hundreds, and a lot of them, of course, were suggestions for names. We would have named it Minerva, the goddess of wisdom, had it not been given to one of the asteroids. The reason for considering that at first was that Minerva being the goddess of wisdom, this was to honor Percival Lowell for his wisdom and prophesying and calculating for the 9th planet. So we had to let that one go. You know, it's customary to name planets after mythological deities. We also wanted to consider the fact that we wanted the name we've selected that would stick, not be changed. Well, there was a very egocentric astronomer who was kind of a pain in the neck, and he strongly urged the name of Cronus. Well, to heck with him, so it was Pluto. As you probably may or may not realize, that the fissionable element plutonium was named plutonium because we named the planet Pluto. I don't know whether you were aware of that or not. If it named it something else, you would not have known it by the name of plutonium. That's the only contribution I made to the nuclear age. Well, of course, I say the planet was 10 times fainter than it was expected, and again we had even stronger uneasiness that the body may not be big enough to produce the disturbances on Uranus that Lowell used. And so the director told me to continue the search of the zodiac, and so I continued this and so on, and did so for the next 13 years. And of course, after the orbit was computed, they found images on old plates as far back as 1908 in some places in the world, and this gave us a much more accurate means along the arc to get a reliable determination of the orbit. And of course, it was also seen that the inclination of Pluto's orbit to the plane of the Earth's orbit was 17 degrees, and this then was another problem. The next one was Mercury at 7 degrees. In order to make a search through the skies for other planets, we would have to take a photograph and scan a much wider belt than just the zodiac, because there might be some planet with even higher inclination, and if it happened to be a long ways from the ascending or descending node, it would be far out of the zodiac zone. So over the years, I photographed and scanned 2/3 of the entire sky for planets, and no more showed up. As I say, Pluto's light was equal to, at that time, to about a candle about 200 miles away, and it was about 5 or 6 times brighter than the limit of the plates. So I went through all these plates. Some of the plates would have several 100,000 stars on a piece, and it would take several weeks to do them. The thinnest star regions, the non-Milky Way regions, had about 50,000 stars apiece, and I could do that not without too much difficulty in about 3 days of hard work. But some of the scanning of plates in the Milky Way, like in Sagittarius, would require 5 weeks of hard work to do one pair of plates, because those plates had 1 million star images on a piece. And I'll tell you, 1 million star images is a lot of star images you have to see, and you've got to see all of them because you don't know which one is going to shift. And so that's why it was tedious. Well, I think now I'll show some slides. Turn the lights down a little bit. We're going to have to turn that light out or we're going to not see anything. Sorry, yeah, okay. You can take this for what it's worth. Does any new planet I discover while in your class remain my property or the property of the Board of Education? There seems to be a little political or legal thing involved here. But I can assure you he's not going to discover a new planet with that little telescope. Next slide shows me a photograph taken in 1928 on the Kansas farm by my father at the age of 22, and this is my third telescope I made, a 9-inch telescope of excellent quality, and that's a telescope with which I made the drawings of sketches of the markings on Mars and Jupiter, and I sent to the Low Observatory, which impressed them favorably, and that's how I got the invitation to come to Flagstaff. Next slide shows the images of a drawing I made of Saturn in the summer of 1929 when I went home on a vacation for 3 weeks. To show you what I could see on Saturn. You see at the top a dark polar region and a white collar, and down below some very dull reddish-brown bands, and then the crepe ring going across the ball. And to the upper left of the ball, you see a shadow of Saturn on the rings. And so Saturn now, since that time, has made 2 complete revolutions around the sun. The next slide shows the same old telescope, but not the same Clyde Tombaugh. Now at the bottom there, you see, at the bottom of the pedestal it stands on is the base of an old Deal cream separator. And the polar axis, if you can point that out, was taken from my dad's old 1910 Buick. And then the other parts from straw spreaders and so on. And so I had to use the family junk pile for some of my mining. And of course, in the meantime, I had, this was taken just a few years ago, and of course I had learned a lot more astronomy and had been over the universe and had a very different outlook. Next slide shows one of the jobs I had to do at Flagstaff. You know, Flagstaff is notorious for snowfall. We always have between 6 and 15 feet of snowfall there every winter, and winter lasts about 8 months. I've seen 2 feet of snow there in early October. I've seen several inches of snow in June. And even in May, we would have 8 inches sometimes. Well, this was a canvas-covered dome that housed our 42-inch reflector. It was a rather cheap dome. The observatory wasn't rolling in money, so they had to do things on a little less expensive means. And, of course, after every snowstorm, I had to get up on top of that and push the snow off and then pull it down from the sides. This dome practically fit on the bottom of the dome near the ground. And so I would estimate that I probably pushed off at least 100 tons of snow from that thing over the years. So this was my snow job. Next slide shows the 13-inch telescope dome on the 2nd floor in the yellow pine forest at an elevation of 7,300 feet above sea level on the Mars Hill, which is a volcanic mesa west of town. And the next slide shows the telescope itself. It's not a terribly impressive instrument. It's only 5.5 feet long. But at the upper end of the tube is a 3-element Cook wide-angle astro lens, 13 inches diameter, 33 centimeters in diameter. And the large 14 by 17-inch plates were put in the lower end of the tube, and you see the center tube on top, which is the guide telescope where I had to keep the guide star on the illuminated cross sets for a 1-hour exposure. And then the large worm wheel at the foot of the polar axis to turn the telescope slowly westward for the long exposures. The next slide. This shows the rear end of the telescope and the large plate holder. And the next slide Shows a picture of me taken in 1931, 1 year after the discovery, at the guiding eyepiece of this telescope. Next slide. This is a picture of me taken at the blink microscope comparador in 1938 at the age of 32, where I sat for a total of 7,000 hours scanning plates to find planets. The plates, a pair were put on each side, and an optical system and a shutter that would alternate the views of the plates. And this way, I was looking for something to shift position. Now, stars don't show any shift in such a short time. Planets do. And the next slide shows the discovery areas of Pluto, of which one? He's going to point out some configuration of stars, and that should be the January 29th instead of the 30th, but this had a 6-day interval. If he points out some stars in one field, and you see the same set of stars on the other side, but no change. Then you point over here, no change. Okay, let's go to where Pluto is. See that double star? And a little image right above it? Well, 6 nights later, it isn't there. It's shifted position to a position. That's it right there. You see that one there, the star with 3 little ones around it? Now, there's nothing beyond the second one on the first one because it's above that double star. And so that's the shift of Pluto. The shift in 6 days' time was 3.5 millimeters on my plates. This sky area represents 1 part in about 60,000 of the total sky area I searched through for planets over 14 years. And you might point out, you see that one galaxy up there, Bernie? The upper, yes. That's the image of a distant galaxy at a distance of about 700 million light years. And so I got to see all kinds of things. And of course, next slide, we'll skip and go on because it's just a positive of the other. Go to the next one. This shows a small section of the plate taken on the 19th of February where Pluto had moved to from the discovered position. And some people have said, I don't see why it's so hard to find out. Planet had an arrow pointing to it. Next slide. When we plot the position of the planet from night to night, we get a trace like this. And the lower right part shows the discovered positions, how it slowly retrograded to the west and came to a stationary, apparent stationary, then back again to the east. And the gap between that and the next year or fall was when it was behind the sun and the components were added instead of subtracted. And so the next September in the morning sky, we retrieved it and followed again through a stationary, then back to the next opposition. The distance it traveled at that time from one opposition position to the next a year later was about 1 4/10 degrees. I might mention that we wanted a short focal length camera to take in a large area of the sky for a given size plate. So it was not a high resolution telescope. It was quite unsuited for looking at Mars. But we wanted to, but having the light power, we could record the images of lots of stars on a given size plate. And so that's the way we had to do it, and this was a very fine instrument indeed. That star in the center part is the guide star. The ring around it is false. It's a halation effect of photography because the star was overexposed and gives that ring. Let's see. That's the region in eastern Germany, lots of stars. Next slide shows the image of the nearest spiral galaxy, M33, south of the Andromeda Nebula, about 10 degrees. This is the way it looked on my plates. I always used the original plates with the star images black and the galaxies and stuff black, and I covered 2/3 of the sky over the 14 years, and so as a result I acquired a negative view of the universe. Next slide. When we compare the predicted orbit by Lowell, which is the outside one, and to the actual orbit, it's rather a good agreement, and yet we know now that it was all coincidence. This predicted an actual orbit really was a better fit than was involved in the discovery of Neptune in 1846. We are in the very middle part, the center part of the solar system. Next slide. We'll go on the next one. That's just another orbit of Pluto. Let's go back again one. Show them the perihelion portion, Bernie, where Pluto is right now. Down a little further. Inside. No, down to by that lower figure. That's it, right there. Pluto's orbit is just slightly inside Neptune's orbit. And that's where it was on the 5th of September of this year. And it will then start soaring outward into the solar system for the next 124 years. And it will go way on out, far beyond the orbit of Neptune. Next slide. We'll go on the next one. Here you see a star map showing the constellation of Orion on the lower left. And the shaded area is the part of the sky starting from the great square Pegasus to Perseus, where I counted 1,800 galaxies in 300 square degrees, 40 degrees long. This was twice as high a galaxy count as I encountered anywhere else in the search. So this was really a super cluster of galaxies. And some astronomers think that was a more important find than the finding of Pluto. And then, of course, I found a lot of clusters of galaxies and so on. Next slide shows the 13-inch telescope. This was taken 24 years after the discovery, taken in 1954. And in the background is my wife, Patricia, and our daughter, who is now a grandmother of 6 grandchildren, and our great-grandchildren, and our son Alden there, who is now a vice president of the First National Bank in Las Cruces. Next slide. This shows the area of the sky that I scanned for planets. This is a complete picture of the sky, and all the shaded areas what I actually scanned on under the blink comparator. We photographed all of the part of the sky, and some of it, of course, in the upper part was not scanned because World War II came along. I was in the military draft, and I was assigned to teach navigation in a Navy school for 7 semesters, and so those places never did get examined. Now, if there's a planet in that region that's yet undiscovered, you just have to blame it on Adolf Hitler. I went as far south, the ladder that wasn't as strong, almost scraping the horizon on the meridian at latitude of Flagstaff, which is 35 degrees, and they even had Omega Centauri on my plates, and just a little north of the Southern Cross. I couldn't quite see the Southern Cross. And so you see, I did scan the sky at a considerable distance from the ecliptic, which is the plane of the Earth's orbit, and the center of the zodiac belt. And I would have found planets of considerably higher inclination than Pluto if they were there. And so that shows what kind of work I did, and I saw a great deal of the sky. Next slide shows on the left the image of Pluto taken by the Naval 60-inch telescope at the Naval Observatory west of Flagstaff, greatly enlarged. Those black specks are not star images, they're plate grain. And the little bump on the image is the image of Pluto's satellite, Charon, and it was never better separated than that because it's very close to Pluto. The atmosphere smears the image, and is really, the photographic image is considerably bigger than the real image, what you've seen on the right. Now, now the plane of the satellite is edgewise to our view, and so for the last 3 years, Charon, the satellite, has been passed in front of Pluto and behind Pluto, and being carefully observed with a photoelectric photometer to watch the change in brightness and the duration. And from this, we got rather accurate values for the diameter of both bodies, which then, in the sense, and knowing the satellite there and the radius out from Pluto and the period, using Kepler's third law, harmonic law, this permitted us to determine the mass with fair accuracy. And it turns out that now we can calculate the mean density, and turns out to be less than 2, and so that indicates that a good deal of the mass of Pluto and its satellite is ice. Next slide. This shows the belt of Orion, as appeared on my photographic plates, considerable detail, and all those star images there and so on. I can guarantee that not a single one of those specks of light is an image of a planet. I saw them all to test for shift. On the lower left, you see a dark indentation, which is a Horsehead Nebula. And the next slide is one that was not taken by me. It's taken by color film on a large telescope, how beautiful it is, shining by the red light of hydrogen alpha. And you notice on the left, there are only a few stars, and quite rich on the right. Behind those few stars is a great dark dust cloud blocking the light of the stars behind it. And the stars you see there are in front of the dust cloud. I encountered a couple of hundred of these dark nebulae in my planets. I saw them on the plates, and some of them kind of gave me the willies because a few were so near, not more than a few hundred light years away, with not a single star in front of it. And I think one of the causes of the ice ages is not due to some orbital cycle periods or so on, but that the sun, in going around the center of our galaxy once in 200 million years, has dragged the solar system through these dust clouds and cut down the transparency of space between the Earth and the Sun by 5 or 10%, and that would cause an ice age. I think that's much more sensible than some of the others proposed. Next slide. This is the Rosette Nebula east of Orion. Probably some of you people have seen it with your telescopes. It's fairly large but faint. And this is right in the heart of the Milky Way east of Orion. And I remember seeing this object on my plates. Of course, I didn't see it in color like this, but the stellar limit here is about the same as I had on my plates. And you see there's an awful lot of stars there, and you realize that every one of those specks of light is an image of a distant sun which could have a solar system of planets on its own. And I'm sure in that region right there probably are several alien civilizations at this very moment. Next slide. In 1969, the observatory wanted me to come back from Las Cruces to run a documentary story on the discovery, and this is why. So I went up there. We got the original discovery plates out of the vault room and put them on this machine. And so that's how this picture got made. Now one of the plates is in the Smithsonian Institution in Washington, D.C., and the other's in the vault room at Lowell Observatory. If you're ever in Washington, D.C. sometime, look in the building on the Smithsonian and you'll find it there. Next slide. This is the southern Milky Way, and the upper left at the very top is a Scutum star cloud, and then the big bright area is the Sagittarius star cloud, and to the right is the Scorpius star cloud. And this area is about 30 degrees square. Now this was taken by a small camera riding piggyback on the equatorial mountain or through a long exposure. And I say this is the worst region of all to look for planets. This region of sky required 9 pairs of plates, 14 by 17-inch plates with a 13-inch to cover it, and recorded 7 million different stars. And so that was very hard to go through, but I did. Next slide. This shows the Scutum cloud with a more powerful camera resolved in a large number of stars, and one of them is at the upper left. And so I saw one of those images. Next slide shows Pluto and a satellite. This is sort of a diagram, of course, obtained from reducing the observations, the full electric observations. And the next slide will show really the large area of the planet that is covered in a total eclipse of the sun by Pluto's satellite Charon. Wouldn't it be something if we had a total eclipse of the sun covering that much area on the Earth? It'd be something, wouldn't it? Next slide. This is a log graph showing the relationship of a possible planet with a 5% reflection power. Of course, we know it was higher, Pluto was higher than that now. To the ordinates up and down as a function of distance from the sun, logarithmically, and the size of the diameter of the planet horizontally, and the resulting photographic magnitude. Now, just to the right of that thing at the top there, it says MO for moon, we have PL Pluto. Well, now we know that it should have been to the left of it to be correctly on this diagram. Next slide. Okay. Can't get to go to the next one. The next slide is blank. There we are. This is my 16-inch F10 Newtonian on Las Cruces, all hand-built by me, even doing the mirror, making the mirror. This telescope is bolted together out of channel iron, right angle iron, and straps. A total weight of about a ton, all hand-bolted. I estimate I drilled through between 15 and 20 feet of steel drilling bolt holes for this. The tube is 15 feet long. The next slide shows it from the south on a tie platform, and the eyepiece up above my head there. And it gives beautiful definition. A year ago, last August, I had 2 nights of very good seeing, and I was able to see the radio spokes and ring B Saturn with it, of the power 524. Very sharp image. So I have a lot of fun. I have a real powerful telescope right in my own backyard. Next slide. Here I am polishing a 16-inch mirror on a lap of pitch and barn sight, and you see this this weighs about 50 pounds, and this kind of work always has you over a barrel. Next slide. This shows a drawing I made of Jupiter in 1936 at Flagstaff. Every marking is real. I took these from Slifer's photograph and made a color record and made this drawing. Now, in this 16-inch telescope, I see detail considerably finer than that, so I have some great views of Jupiter. In the upper left, you see the famous red spot. Next slide. This shows a 24-inch telescope on A Mountain east of the campus in New Mexico State, about 1,000 feet above the campus. And this is a 24-inch mirror, a Castron system, with an equivalent focal length of 150 feet to give a large-scale photographs of the planets which we maintain there since 1958. We have now in our plate files about 1 million planetary images of Mars, Venus, or Mercury, Mars, Venus, and particularly Jupiter and Saturn. Each one was a hand-selected shot by looking through the monitor eyepiece to select the best moment when the scene was settled down. And so these photographs have been of great value working with NASA and helping to plan the deep spacecraft missions. Next slide shows observatory on the mountain there. The Oregon Mountain's in the distance, about 14 miles away. And this is our 24-inch telescope on A Mountain, as we call it. A stands for New Mexico Aggies and also stands for astronomy. And it's a very fine sight to get photographs of the planets. I think that concludes the slides, and we can now have the lights. Now, I tell you that I sometimes get letters from young, ambitious people, young people who have written to me and says, please tell me how to find a planet. I'd like to find one. Well, the book was in press in 1980 when I thought of this. I didn't think of it soon enough to get it included in the book. And in case any of you are interested in seeing these 10 special commandments for the would-be planet hunter, they were published in the Sky and Telescope September 1980 issue, September 1980. And I'll read these to you. And these are the do's and don'ts in a nutshell. Behold the heavens and the great vastness thereof, for a planet could be anywhere therein. Thou shalt dedicate thy whole being in the search project with infinite patience and perseverance, which about taxed it to the breaking point at times. Thou shalt set no other work before thee, for the search will keep thee busy enough. Thou shalt take the place at opposition time, lest thou be deceived by asteroids near the stationary positions. Thou shalt duplicate the plates of a pair at the same hour angle from the meridian, lest refraction distortion overtake thee. Thou shalt give adequate overlap of adjacent plate regions, lest the planet play hide-and-seek with thee. You always have to overlap when they gain time. Thou must not become ill in the dark of the moon, lest thou fall behind the opposition point. And so I did stay pretty well, but a couple of times to save the series, with the moon coming out, I had to get them done. I was out of the dome in freezing temperature with a temperature of 104. All right. Thou shalt have no dates except at full moon, when long exposure plates cannot be taken at the telescope. My social life was practically zero over those years. I was a bachelor then, and of course, even on cloudy nights, if there's no moon in the sky, I had to have the plate orders loaded, ready to go out and take some plates if it cleared. And only around full moon could I count on an evening of my own. And after all, what girl would be interested in a boyfriend who could only have dates at full moon? Many false planets shall appear before thee, hundreds of them, in fact thousands of them, and thou shalt check every one with a third plate. I estimate that over those years that I checked with a third plate about 10,000 possibilities in the last magnitude, and none of them worked out. So if you're going to make a planet search, you've got to have 3 plates, otherwise it's not worth doing. You just have a lot of suspects and it's a bunch of maybes. So I wanted to make it thorough. If nothing showed up, I would say such a planet does not exist. And I can say that lowest planet X does not exist, because there isn't anything there of that size. I remember that one of the people at the Naval Observatory, he was quite sure that there was a planet about 2 Earth masses out there a little beyond Pluto, and he was very sure of it. And he said to me one day at a meeting, I said, "Could you have missed a 14th magnitude planet?" And I said, "No way. I guarantee it's a 16 and a half and maybe even 17 places." And I said, "If you think I missed something, you're welcome to re-blink my plates, all of them." 7,000 hours worth. And the last commandment, thou shalt not engage in any dissipation, that thy years may be many, for thou shalt need them to finish the job. Thank you.